Alright folks, so today before we pull the face off this Sansui AU11000, I want to discuss some of the components I'm using and why they were chosen. In the case of capacitors, you'll see that I've used film capacitors in place of some of the ones that were installed in here. And I want to touch briefly upon why that is. Now, whenever you read about or learn about electronic components, you'll often read about what are known as ideal components, which of course don't exist in the real world. But they will have certain parameters, like an ideal capacitor would have zero leakage, zero ESR, zero inductance. In practice, these things do exist. We do have to take them into account. And manufacturing and material sciences have gotten so good to the point that we can select certain parameters and approach very closely to that ideal. So therefore, you can buy low leakage capacitors, or you can buy low ESR capacitors, but it's very difficult to get those in a single package. Now, when we're talking about lower levels of capacitance, film capacitors are very close to ideal. So whenever I see a low leakage or a capacitor in the signal path, we change those out for films. And let me show you what I'm talking about here. Low leakage capacitors are these little orange jacketed guys here, okay? You'll find these a lot in coupling or in tuner circuits, and those are replaced with film capacitors. Now you can see these are physically fairly large, and they're not cheap, but they're ideal for coupling, they're ideal for low leakage applications. So this is why they were chosen. Now when it comes to semiconductors, I do take the coward's way out, and I will see if there's an accepted substitute, but after doing so, I will compare the data sheets from the part I want to replace with the recommended replacement. And you want to check parameters such as breakdown voltages between all the junctions, emitter base, emitter collector, and you also want to check what's called the FT, or the operating frequency. FT is a frequency at which the gain of the transistor goes down to 1. So you don't want to put in very high frequency transistors in a location where low frequency ones are used, or you run the risk of oscillation. You're not going to hear this, but things may get hot, and you can see them on an oscilloscope, which is one of the reasons it's such an important tool. So having said all this, we're going to go and pull the front off of this and see what we're going to get into. I've never been into one of these, so everything's been pretty much a surprise. Okay, one detail I forgot I wanted to touch upon was why it was so important that these do not contact the cover. And I believe I mentioned they're electrically connected to the negative terminals here, which means any one of the negative supplies here is going to be available right here. And we can't have that. So what I've done to prevent any short circuits when we put this thing back together is I have put some fish paper right along here where these would make contact. Now, interestingly, I wasn't able a while ago to find why they call this stuff fish paper, but I think I cleaned up my search terms, and basically it was a woven silk product back in the 1700s, and later on they discovered that if they soaked this woven silk product in fish oil, it would become a very good insulator. And fish paper was invented. Now, it's not made out of woven silk, and it's definitely not soaked in fish oil, because I'd be able to smell that, but that's where it got its name. So we put some of that on here to prevent any kind of short circuits when this thing is reassembled. Now, I've delayed long enough. Let's get the face off of this thing and see what we got going here. Okay, anyone that's watched any of my videos has seen that I always take a bag and I mark what's going to go in that bag, and I have a large, call it a master bag, that has all the parts I've taken off of this amplifier so that I can get this thing back together. Sometimes it's quite a while between first starting to work on it, ordering parts, getting everything in, and then reassembling it. So it's very helpful to have everything marked, no matter how self-explanatory you may think it was at the time. All the knobs on the Sansuis I've worked on have been locked down with Allen wrenches. The 717s took a 1.5 millimeter, and I've pretty much worn out my cheap Harbor Freight 1.5 because I've worked on so many of those. Fortunately, this one takes a 2 millimeter, and I assume all the rest of the knobs will also, but we're going to find out. But I did want to share with you this methodology because this works out really well. All right, so we got all the knobs off. They're all bagged up here in a bag that says knobs. And the only other thing we have to do to get the front off of this is there are screws in the top and bottom that need to be removed, and now we should be able to get the front off. Okay, so now our front panel is off. We set this off to the side. We're going to clean it up, and I'm going to try and touch up the Sansui logo a little bit, but anyhow, you can see it's got a bunch of crap on it, but once it's taken out like this, a lot easier to get to. We have a button we need to replace here, like the power switch. Not sure where it's going to come from, but we'll have to keep our eyes open. So now that we're in here, we're going to have to remove the inner cover. Okay, so after looking at this a little closer, remember I've never taken one of these apart before, I think what I'm going to do is I'm going to concentrate on this area right here. This is the F2573 tone board. So I'm going to pull this out. We're going to replace any components that need to be replaced, and very important while we're in there is we're going to clean all the switches and pots really well. And that brings us up to another discussion. I want to talk about chemicals and where their use is appropriate. Okay, so I've got the F2573 board out, and I, of course, have made a bag for all the hardware that mounted it. Now, what I use is leftover parts bags from my preferred parts vendor. They're really handy for this. Whenever I reorder parts, I take the empty bag and I use them for stuff like this. I have another one for everything that came off the inner faceplate, another one for everything that came off the outer faceplate, and they all go in this bag right here. This is the master bag, we're going to call it. But anyhow, I want to get back to talking about the chemicals that we're going to be using. Now, switches can require, or let me put it this way, pots require a gentler cleaning agent that we're going to use on switches. Switch are just metallic contacts, but pots are carbon bonded to traces, and we don't want to spray anything in here that is going to dissolve those or cause any kind of damage. So the only thing that I spray into pots is Fader F5. Nothing else goes into a pot on my watch. Now, switches are another story. I will usually take a non or zero residue cleaner like this one is, and I will spray them out with this, and I'll work them. And I saw an interesting tip on Mr. Carlson's lab. What he says he does is he sprays a pot, waits 24 hours, and then sprays it again. His theory being that the initial application will loosen up any crud inside there, and the second application will flush it out. Now, what I usually do is I hit the switches really well with the zero residue cleaner, and then I follow up with some of this super contact cleaner with polyphenol ether, which sounds like nasty stuff, but anyway, I'll put this in because this will leave a bit of a lubrication, which will also help break things down. Then I'll flush it again and put a final application of this. Now, you'll see everybody rave about Keg products, and they are very good. But our Canadian friends find them to be a little too expensive. So they've been using MG chemicals, and I've found some of these on sale at a local parts house. And I can attest that these are very good products as well, and can usually be had a little cheaper. That said, there's a Guitar Center not too far from my house where I can get Fader Lube and D5. Now, I do have D100. I don't believe this has a solvent in it, but it is the call it the active ingredient that they put in Deoxit D series. Okay, so I've got the initial cleaning agent sprayed in all these switches and pots, and this would be a good time to mention, you don't have to hose these things out. I have had this can of fader lube and I use it a lot for several years. You just need a little bit. Spray it in there, work the pot, wait 24 hours, spray a little more in there, and I've never had any problems, never had any returns. But it's very important after you spray these that you work the switches to rub past the contacts and help break down any tarnish or oxidation that you find inside. Okay, so the F2573 board did not require a lot of parts replacement. There are two 3.3 microfarad bipolar coupling capacitors that were here. Now they were electrolytic, and they look like this, and they were an excellent candidate for replacing with film capacitors. Now I pulled them out, and let's take a look at the LCR meter. And if you get a good look here, you can see that one of the ones I pulled out, instead of 3.3 microfarads, is reading 2.5 microfarads, but 10 ohms of ESR, equivalent series resistance. Now I replaced them with film capacitors. These are WEMA 3.3 at 50 volt. These were 3.3 at 25, so these are fine to replace it with, but I want you to see the difference on the meter when we look at the film capacitor as opposed to the older electrolytic. You can see this is much closer to the 3.3 microfarads, but more importantly, our ESR is a fraction of an ohm. It's 0.2 of an ohm versus 10 ohms for the old component. Now these are coupling capacitors, so film should yield lower distortion and just better characteristics overall. So whenever I find coupling capacitors of a small value, I always use films. Okay, so this is our 2573 board. Replace those. Going to leave it out so we can spray these all again tomorrow. And then next we're going to get into the 2576 board. Now this has some of those dual transistors on here that we're going to replace, and some capacitors. I haven't looked at the schematic, but they may also get replaced with film. And of course these switches will be cleaned while we have this out. Now in order to get these dual transistors, we take two KS8 992s, because remember these are PNPs, and we have to match them up in order to make a pair that we solder together. Now I matched them up using a Peak Atlas DCA75, this guy here. It's not important that you use this particular unit. There are many cheap component testers on the market that will do a fine job for this. But in any event, I go make myself comfortable at my desk and I write down all of the HFE or gains for these transistors, and then I go and I pick two that are very close in value. So for instance, we have, let's see, we have a 430 here and a 431 here. So those are close, certainly close enough for this application. And then we have to solder them together, because if you remember, these dual transistors here pin out base, collector, emitter, collector, base. So they are two transistors with a common emitter. And what we do is we solder these. Now, with this one, these pin out emitter, collector, base. So if we look at the one with the flat side facing us, we have emitter, collector, base. Now this one's facing away from us, so it's going to pin out base, collector, emitter. Now the reason that we invert this or turn it over is so that the emitters are tied together. And that's a spam risk call that I don't need to answer. Oh my God, go away. So that gives us our base collector, emitter collector base. And this is what we use to replace those. Alright, so I've gone through the F2576 board, and as I suspected, these were bipolar coupling caps, and they were replaced with films. The old 1 microfarads were pretty bad and had very high levels of ESR. As you can see here, the film capacitors measure so much better, and I think they're going to make a big difference in this application. The dual transistors were replaced with 2 KSA 992s that were put with their emitters tied together. And one thing I didn't think about when I did this, but makes it kind of nice, is these are now impossible to put in backwards. Since they pin out base collector, emitter collector, base, they are more or less, I guess the term would be palindromic. They're the same one way as the other. So even I can't screw this up, and that's saying something. Okay, next up we have the 2575 board. This looks very similar to the 2576. We only have one selector on here, but it looks to me like we're going to be replacing the same parts. We're going to replace these coupling caps with films, going to replace these dual transistors with 2 KSA 992s. Okay, so I finished up the 2575 board. Basically did the same things to it I did to the other ones. I replaced the dual transistors with back-to-back KSA 992s. And I want to take a minute and show you the process of this. I basically take one, I bend the emitter lead out like this, and then I wrap it around the inverted or backwards one so that the emitter leads are side by side. And I grab with a pair of hemostats, stick the hemostats in the vise, and I just solder that leg together and cut off the excess. And now I have 2 transistors that, like I said, I can't put in backwards. By the way, I've been spraying these to clean them out, and I always make sure to use a plastic safe contact cleaner. Now, in this case, I'm using this WD-40 contact cleaner because it specifies plastic and metal safe and also leaves no residue. So I have quite an abundance of chemicals here. This is just a few of them. I've got cans upon cans for all different applications. I probably got more chemicals than the average meth lab, but you know, so this is what it takes. You want to do these things right, and you don't want to cause more harm when you're trying to do good. Okay, so the last board we have to get is down in here, and that is the F2574. Now, I don't like to do multiple boards at once because if you have a problem, you don't know where that problem is. However, I don't want to reassemble this whole thing and take it back apart and reassemble and take it apart. So I'm going to do these boards and double check them before I put them back in, and hopefully there will be no reason to disassemble them. Anyway, we're going to call it right here. I'm going to edit and publish this video. I enjoyed making it. Hope you enjoyed watching it. And as always, I like giving back to the community that's given me so much.